Hey kids, welcome back to school again. So here is the last thing we are doing to help you get through the quiz, and that was the stoichiometry highway, introducing grams as part of the equation. And when you ever need grams, if ever you need grams to do any of these problems in chemistry, you're going to need to use the periodic table and go through the periodic table. The mole to mole relationship, as we've been doing already, comes from the balanced equation. So for every one of these problems, you're going to need to use the balanced equation to figure out the mole to mole ratio. However, if you start with grams and you need to get to moles of some other substance, you will need to go through the periodic table first and then go through the mole to mole ratio of a balanced equation. And if you start with moles of one substance and you need to go to grams of another substance, that's another time you'll need the periodic table. Let's see it play out here. So mole to mole comes from the balanced equation, and grams to mole comes from the periodic table. That is where you need to start with your notes. All right, so here we have a balanced equation where there's 4 moles of aluminum and 3 moles of oxygen, and they form 2 moles of aluminum oxide. And the question's asking us if we have 27 grams of oxygen. So we're starting with 27 grams of oxygen, which is right here. And it's asking us how many moles of aluminum are needed. So the question is asking us for moles of aluminum. So we're going to have to go from the red into the blue. So the first thing we're going to do here, since we're going to go from the red into the blue, is start with what we were given, which is 27 grams. 27 grams of O2. And in order for us to get that into this equation, we're going to need to turn that 27 grams of oxygen into moles. And to turn that 27 grams into moles, that means we need to divide by, from the periodic table, 32 grams of O2. Oxygen weighs 16, there's 2 of them, so that's a total of 32 grams, and that's in 1 mole of O2. And when we do that, we will figure out that there are 0.844 moles of oxygen. And now we need to use the balanced equation to convert that moles of oxygen into moles of aluminum. So the 0.844 moles of oxygen, we need to change into moles of aluminum. And to do that, we will then know that there's 4 moles of aluminum for every 3 moles of oxygen. And we get that from the balanced equation right here. So this and that one over there. And that gets us to 1.13 moles of aluminum. So we turn grams into moles of oxygen, and then that moles, we then had to use the balanced equation to go from moles of oxygen to moles of aluminum. This we got from the periodic table, and that we got from the balanced equation. And if you look at our highway, we had to get to moles of aluminum, and we started with grams of oxygen. So we had to go to the periodic table, balanced equation, and then we were done. We didn't have to use the periodic table a second time. All right, let's try this one then. So for this one, we're looking at C3H8. So that is our propane. So here's C3H8. And we are given that we have 94.2 grams of propane gas. So we are given 94.2 grams of C3H8. And what we're going to, the other substance, the different substance that we're going to, is moles of water. So we need moles of water. The excess oxygen is just telling us that because we have a bunch of oxygen, this will be our limiting reactant. So this propane will determine how much water we make. All right, so let's look here. We have grams, and hopefully by now you realize on our periodic or on our highway, since we're starting with grams, we have to go from grams to moles. And we get that from the periodic table. So this is going to come from the periodic table. And you will see on the periodic table that C3H8 is there's 12, they weigh 12, and there's three of them, so that's 36. And the H, there's eight of those, each one weighs one. So that's a grand total of 44 grams. So that's 44 grams in 1 mole of C3H8. So that gets us to the C3H8, which we now need. So if we do that out real quick, you'll see that's 2.14 moles C3H8. Okay, so then that moles needs to go into this equation and spit out moles of water. So we need to convert moles of C3H8, and we know that 1 mole of C3H8 will give us the 4 moles of water, and we get that from the balanced equation. So this is from the balanced equation. And basically the 2.14 times 4 divided by 1 gives us the 8.56 moles of water that we would get in this situation. So if we start with 94.2 grams of C3H8, we will get 8.56 moles of water. Going back to our highway again, we started here with grams of C3H8. We used the periodic table to turn it into moles, and we used the balanced equation to get that into moles of water, and then we were done. We didn't need grams of water. If we needed grams of water, we would have needed to multiply that with the periodic table weight of water, but we didn't. Here's one now where that might happen. We have 53.3 grams of sodium chlorate, NaClO3, which is this one. And we need to figure out how much sodium chloride. So grams. So now we're going back to grams of sodium chloride, which is that one. So there's two sets of grams. So looking at our highway here, we're going to need the periodic table twice. There's two sets of grams, once for the sodium chlorate and once for the sodium chloride. So let's start with our given. We are given, not yellow, but red. We are given the 53.3 grams of NaClO3. And we need to turn that into, we are headed toward, not that one, not what I wanted. All right. Escape that, I guess. That worked. All right. We are headed toward grams of sodium chloride. NaCl is what we want. So we need to use the periodic table, and we need to add up what 23 and 35.5 and 16 times 3 are. So sodium is 23 and chlorine is 35.5 and oxygen is 16, and there's 3 of those. And when you add all those up, what you get is 106.5 grams of NaClO3, and that's in 1 mole of NaClO3. So we've gotten out of grams, but now we're in moles of NaClO3, and we got to get to grams of NaCl. So here's where we got to do our color change. We got to go from the 2 moles of NaCl, so from 2 moles of NaClO3, and we got to get into 2 moles of NaCl. So that will get us to NaCl. And then to get to grams, we're going to have to go from moles to grams. And again, we're going to need the periodic table here. So this will be the periodic table. And this was the balanced equation. And this was the periodic table as well. So this was one where we needed all 3 steps. So if we add up Na, which is 23, and Cl, which is 35.5, you get a grand total of 58.5 grams. So that's 58.5 grams in 1 mole. So now you multiply 53.3 times 1 times 2 times 58.5, and you divide it by 106.5 and divide it again by 2, and what you get is 29.3 grams. So that should give you, that's how many grams of NaCl this reaction will make. And we're actually going to do some labs this week where we start weighing stuff so you can figure this out. The last one on your notes here is that copper reacts with acid to produce copper 2 nitrate. So in this case, we have the 2.50 grams of nitrogen dioxide. So we're starting here, 2.50 grams of nitrogen dioxide, which is that one. And we want to know how many grams of copper are needed. So somebody orders 2.5 grams of nitrogen dioxide, and we want to know how much copper do we need. So how many grams of copper do we need to go get? So we're starting here. Our given is the 2.50 grams of nitrogen dioxide. So we're going to start there. And we need to get all the way to grams of copper so we can figure out how many grams of copper to start with. So our first stop, since we're at grams, is to use the periodic table. And we got nitrogen as a 14 and oxygen as a 16, and there's two of them. So when you add all that up together, that's 32 plus 14, and you get 46 grams. That's 46 grams of NO2 for every 1 mole of NO2. So that gets us out of grams, but now we're in moles, so we're going to need to use this periodic balanced equation. So we know there are 2 moles of NO2 for every 1 mole of copper. Oops. Every 1 mole, right? We need to stop doing that. 1 mole of copper, right? So that gets us out of moles of NO2 into moles of copper. We still need to go to grams, and to get to grams, we're going to need to get out of moles into grams from the periodic table. So 1 mole on the periodic table of copper weighs 63.5 grams. And so we're going to multiply 2.5 times 1 times 1 times 63.5 and divide it by 46 times 2, and you get 1.73 grams of copper. All right. So that ought to make your homework a little easier and also your quizzes a little easier. So in these cases, we always had one given, and we're going to discard all that stuff. I hope that helps, and I'm looking forward to seeing you tomorrow.